Hello, welcome to our CS225 final project presentation. I'm Amy.
I'm Cindia.
And I'm Christina.
So for our final project, our goals were to use the OpenFlight database and load airport and route information into a graph. And then we implemented the BFS, Dijkstra, and landmark algorithms in order to traverse this graph.
As a team, we were able to effectively conduct productive meetings throughout the week, which as a result led us to meet our goals. We were able to complete all 3 traversals as well as implement an executable for each traversal where the user is able to input a routes file, an airports file, the source, destination, and landmark airports. After running the executable, the user will be able to see an output of the traversal in the terminal.
So from the OpenFlight's website, we use the routes.txt and the airports.txt datasets. Routes.txt only includes data on the source and destination airports of each route, while airports.txt included specific details on each airport, such as its main city served, land latitude, and longitude. Since the airport IATA code is the common feature between the two datasets, we use it to match and locate information for each airport in each file. It was very important to ensure that all of the airports in routes.txt had a corresponding entry in airports.txt in order to retrieve its latitude and longitude coordinates. We removed any airports, which were very few in number, that did not satisfy this requirement. Since we read in each file as a CSV file, we also ran into an issue where some airport names contained commas in the name. As a result, we had to implement a workaround to account for that specific format. There were also some null values present in the data for some airport IDs, so we removed those respective airports as they were unusable. And on the next slide, there's an example of some code that we used to clean the data.
As for how we coded each algorithm, for BFS, we referenced our previous labs and MPs to try and figure out how the algorithm might work for our data sets and our goals. We decided to just create a function that can be used to find the shortest path of an inputted graph using the source and destination airports that are also inputted. Following this decision, we just mimicked this sort of function structure for the rest of the algorithms as well. So for Dijkstra's, it was a little bit more difficult to reference older assignments. So we just did some research using the final project AMA, most recent lectures, and also just online resources. To code this algorithm, we mainly just use a priority queue, and Amy will go more into that into the code and executables later. So for the landmark path algorithm, it was relatively simple to implement compared to the other ones. We just used the Dijkstra's algorithm twice, once from the source to the landmark airport and another time from the landmark to the destination airport. This gave us the shortest path from source to destination that traverses through the landmark airport.
As for how we tested, for each algorithm, we created multiple test cases to ensure that they're working as we expected them to. We created subgraphs using specific airports from the dataset, as well as an overall graph using the entire dataset. For every single test case, we made sure to manually calculate and look up routes and distances so that we knew what the expected result would be. And we also made sure to test for edge cases, such as no path existing between the airports or when the airport code didn't even exist.
Okay, so in order to prove that our algorithms were successful, I'll now go over an overview of all the executables that we have. So we have 4 executables, one each for each of the specific algorithms, and then one main one to run all of them. So in order to make them, it's make run underscore and then the traversal name. So first I'll do make run BFS, and then I can use these command line arguments to input stuff. So I first have the airports file, the routes file, the source airport ID, and the destination airport ID. So this first output for BFS will find the shortest path from the source to destination. So from IQT to CUZ. And we're testing this on a smaller subgraph that we extracted from the large graph in total. And this way we know that this path is correct because we were able to manually trace through and find this as the shortest path. And then this next output is the BFS traversal on the whole graph from IQT, so there's no destination. So it'll just go from IQT through all of the vertices in the graph, and this is the ordered path that it takes through that. And then the next one is run Dijkstra. So it's the same exact arguments here. So airport, route, source, destination. And then this first output that we show here is the shortest distance from TPP to all of the airports in the graph. Yeah, so it's the shortest distances from that to all the other vertices. And if there is no path, then it'll output that. Otherwise, it'll output the distance in kilometers. And then this next output for Dijkstra finds the shortest path from the source to destination, and shortest path in terms of the distance in kilometers. And yeah, once again, this is a subgraph, so we were able to manually calculate these distances and find this route as the shortest. So yeah, we also know that that is correct. The last algorithm specific one is run landmark. So in addition to the previous arguments, it'll also take this last argument as the landmark airport. And then, yeah, it'll find the shortest path from the source to the destination through a landmark airport. So here we have this path, yeah, that indeed goes from source to destination through JUL. And yeah, okay, so lastly, we have the main one that will run all three at once. So we can type in make main, and then it'll take the same exact parameters as before, including this landmark one. Yeah, so then it'll just print out all of the outputs. So BFS, yeah, the BFS methods, the Dijkstra's methods, and the landmark methods. So yeah, that was an overview of the executables. So we can go back to this. Oh, yeah, here's just an example of the output once again.
So for the interesting results, there was actually a couple of facts that we found interesting was, first of all, we discovered that LAX, which I thought was a fairly big airport, did not have any direct flights to Kyoto. Another thing was just that there were a couple of really tiny airports out in the world, one of which is in Peru. The code is TPP, and it only flies to 2 other airports. And then just one more fun thing was just that and this was an issue when we were trying to create tests, was that when the direct path between 2 airports is not always the shortest path between them. Like it might be shorter to actually go to another airport and then go to the final destination. So that was interesting to see too.
Yeah, so as for concluding thoughts, I personally thought that this was a really good opportunity to build upon the knowledge that we learned in lecture, and I feel like I definitely have a better understanding for how each algorithm works.
Yeah, for me, I thought this project was a great way of testing out what we learned in class. I also like being able to work with my teammates on figuring out the best way of implementing the code, and also just structuring our code.
Mm-hmm. And for me, I thought it was really cool to be able to learn about new traversals like the landmark path, and to also be able to apply all of these traversals to a real life application with real life data.
Yeah, there wasn't really anything that I didn't like. I definitely learned a lot, as I said, for the previous question, but either way, if we had more time, I would definitely want to try enhancing the user experience. So such as creating more visually appealing graph outputs, or even a world map that can plot different paths between the airports.
If we had more time too, I think it would have been pretty neat to explore even more algorithms, and maybe even like comparative runtimes on finding the shortest path, and to just see like which situations would be an algorithm more efficient.
Mm-hmm. Yeah, overall, I think we just like learning about the general algorithms and reasoning behind each traversal. and then later adapting and changing them so that the implementations could fit our goals and specific data set. So that aspect I really liked about this project. And yeah, that's all we have. Thanks for watching.